Pandas is a powerful tool in your data science workflow. And so in this video, I want to go over what I'm going to call approximately like the Pandas 101, where I want to cover a lot of the work processes we oftentimes speed through when it comes to reading data, writing data, sorting data, getting the most out of your experience with Pandas. And this is critical because Pandas is usually one of those libraries that we're using in our data science workflows. And so we're going to go over a lot of methods here. I'll also include chapters so you can select just the methods you want to learn more about. Let's get started. So to begin, we're going to import pandas as PD. PD is the common alias used for pandas. So if you look at the documentation, you'll oftentimes see PD dot and then some method name. And this is because this is the alias we're going to use. So instead of using pandas, instead of writing pandas every time we're going to call a method. So I'm going to begin by running this cell, and let's focus initially on getting data in and out. To begin, I have a dictionary with sample, color, and weight, and I'm going to create a data frame simply by using the pd.dataframe method and calling this on the dictionary. When I do that, you see I have a data table, and right now this data table is just a view of the data. If I want to save it as df, I could just create that variable there and then just call df, and I will see it. Note, sometimes if you print the data frame, you might get this view here. It's not quite rendering in a traditional table format. In that case, you might want to use the display option if you want it rendered as a table, just in case. So this is already just a very quick way that you can see the relationship between a Pandas data frame and a dictionary. Next, let's talk about reading data files into our environment. To begin, we're going to use the pd.readExcel, and there are other read methods as well. You can check out the documentation for those, and we're going to point this at a path. The path we're going to look at has this ... which means just to go up one path folder, and then we're going to go to our data directory, and then the coffee file. So essentially what this is doing is it's starting in this cold folder, and it's going to go up to Pandas Basics, back down into our data folder, and then we'll produce this file for us. And then we're going to pass in that path into our read Excel and then preview the first 5 rows with this head method there. When we run that, you can see that we're opening up a data table and creating the variable for our data processing workflows. Similarly, we can also write data files. To do that, we can create another path. In this case, I'm going to go back up and back down into my data folder and create a new file called coffee method table _ new. And I'm going to set the index file to s_id, this column here. And we're going to write that using the toExcel method. And similarly, there are other 2 formats like toCSV that you can use. And I'm going to save that now. If I go into my data folder where this is being saved and check out all the files, you can see that I have my coffee method table _ new that I just created. If I preview that, you can see that I have my table now that was created simply by using the toExcel method. Let's talk about DataFrame basics. To preview the first n rows, we can use the df.head. Now, by default, the head method shows 5 rows, but of course, we can preview 3, we can preview 10, we can preview any number of rows that we have up to the length of the data frame. And this gives us a way to visualize the data. We have a tail method as well, and this will allow us to preview the last n rows, where again, the default is 5. So if I run this method, we are getting the last 5 rows. My data frame goes up to row 10. And so you can see that we are going 10, 9, 8, 7, 6. Similarly, we can preview the last n, so I can set a smaller n value up to the length of the data frame. There's another way to preview a random row using df.sample. And so every time we run this cell, it will preview 1 row at random. If we want to preview 5 rows, we could just select the number for n. And every time we run this cell, we will get a different randomly generated 5 set. And this could be good if you want to subset a larger data table. Additionally, if you can pass in frac, and say we want to preview half the data table. And by passing in a value between 0 and 1, we can preview some subset of the overall size. Again, this is randomized. If you want to instantiate the randomness, you can pass in random state. And every time we run this, it will produce the same data table because we have locked the random state. If we change to a different random state, we will get a different subset of rows based on that randomized state. We can also use different attributes, such as the columns attribute, to preview the columns. And now you can see this is an index type, and we have our columns listed here. So these are the index values across here. Similarly, we can preview the row indices or the row index here. So if I were to set the index to s_id and preview the index, you can see that now we have assigned a new index, and I'm going to preview just that row index, and it will be these values here. So a lot we can do just by understanding how we can navigate and subset our data frame. Let's move on to our data frame summary. Now, this is a good way to understand more of the attributes of your data frame. First, if we want to understand more information about the column types and how many missing values we have, you can use the dataframe.info method. And you can see that our index is a range index with 11 entries between 0 and 10. And that these are our column values that have 11 non-null or non-missing values. The SID column is a object data type, while the per and other columns are integer data types. And then when we get back to the amount of coffee and amount of corn, we're back to our object data type. So this tells you a lot about the overall structure of your data set, which can be important because if you're trying to do a numerical calculation on an object data type, it will fail or do something unexpected. Similarly, if you're trying to apply a string method to an integer or float or some other numeric data type, you might get unexpected results there as well. Additionally, it also tells us the memory used for this data frame. And in this case, we have a little bit over 1.1 kilobytes of memory. And it gives us a summary of the overall data types presented here. And again, this is very important for understanding what your data frame might do or what specific columns might do when exposed to various methods. We can also create some descriptive statistics using the describe DataFrame method. In this case, I just want to preview with a couple percentiles, and I want to include the object data type. The object data type, again, are the amount coffee, amount corn, is adulterated, and my SID columns. When I do that, you see we got something kind of unexpected. And this is because I'm including the object data type. Now, when we talk about percentiles, you should know that this is a computation that should be performed on a numerical data type. So let's get rid of this include line there. And to do that, I just want to comment it out so you can see the transformation. Let's comment that. And when we do that, we get a description that's more in line with numerical values where we have our count, our mean, standard deviation, minimum values, and then the percentiles that I've described, the 0, 50th, and 100th percentile, as well as the maximum value. Just to show you again, when we include object data type, we're getting things like the count, the number of unique values, the top value, and the most frequent values. And this is what I mean when I say you can get very different results depending on the types of data you're operating with. Next, let's talk about subsetting our data frames. And what that really means is how do we filter down to a specific number of rows or columns based on some condition, whether that's an index or a keyword. So in this case, I'm just going to select a single column, and I'm going to use this column as an attribute. And so I want to look at just the per coffee or this percent coffee. And you can see we're getting just these values here, as these are the values in the per coffee column there. So that is subsetting by a single column. We can also subset using this notation here. And this goes back to the fact that data frames are essentially dictionaries. And so we could just call this key there for the same output. Now, generally, this is a more flexible way, a more robust way rather, for subsetting specific columns, because let's say we don't have this underscore. This method will work still. If we did not have that underscore here, we would get a different answer. We would actually get this syntax error because it does not recognize with this space. So if your data frames are not very Pythonic or they have some interesting syntax, you can always rely on this mode using the square brackets and either the single quotes or the double quotes for subsetting a single or even multiple columns. In this case, let me show you that we can also subselect multiple columns by passing in a list of columns. Again, let me separate by line so that you can see. Here we are passing in a list where now I want to subset the per coffee and the volume of coffee in teaspoons by teaspoons. And you can see we have these two columns here. If I comment out one of these columns, you will see we have essentially the answer for a single column. And thus we can pass in any number using this list method there. There are also two techniques called loc and iloc that are really useful for either name-based indexing or numerical-based indexing. In this case, the loc method is for the names of the rows and columns. So I'm demonstrating that I want to use the loc method to subset rows 1, 3, and 9, and then the per coffee, the volume coffee by tablespoon, and the volume of corn teaspoon. When we do that, you will see we're going to slice both the rows and columns to get just these 3 columns and these 3 rows. Now, note that in this case, my index values are numerical indices. So if they were names or object data type, then I would pass in these values as strings in order to use the loc appropriately. Otherwise, you will get an error. When we use iloc, we're talking just index or positional based location. Thus, now I'm going to look at the first position, third position, and ninth position. And I'm going to look at column 0 and 1. When we do that, you see we're getting coffee underscore 90, coffee underscore 70, and coffee underscore 10. These are those positions there. And column 0 and column 1, which corresponds to S underscore ID and per underscore coffee. Thus, this could be a very effective way for subsetting your data based on their index location. One additional thing that could be quite useful for you is using the .loc method for filtering. To demonstrate this, I'm going to create a condition where per coffee is greater than 50. And if we look at condition, you see that we get this list of true and false values. Now, importantly, we can actually pass this condition in and use the values attribute. Let me demonstrate what that looks like really quickly. And we have this array of true and false values. When I uncomment this and we pass in this array here to the .loc method, we will filter our data by the values that are greater than 50. If we were to forget the values attribute, we will get this value error because it doesn't know how to parse this multidimensional key. Thus, it's important to remember to pass in values there. Next, let's talk about the DataFrame.query methods. This is a very important technique because it adds the SQL style to our DataFrame method. Essentially, that allows us to create multiple Boolean conditions for filtering our data. So just like I demonstrated with the .loc method, we can do that with query, but something that feels a little bit more like a SQL statement. Thus, you would read this as I want to look at my per coffee column and find the values that are greater than 50. I also want to look at my vol underscore coffee underscore tablespoon column and find the values that are equal to 3. When we run this query, we will get a new data frame there. And you can see the 2 rows where these conditions both are met. And note, all of this is passed as a string into the query method, and then the rest of the Boolean processing is handled by this method. So it's really nice to take advantage of these sorts of statements where they're true, and you can call in other variables using special syntax. I highly recommend you check out the documentation for the query method, as it is a very powerful technique. So let's dig a bit deeper. If we use the @ symbol, we can access variables outside of this query. So in this case, I have a coffee list, coff underscore list with values 10, 20, and 30. And I want to query my data frame, specifically the per coffee column, for the values that are in coffee list. So I want to look in the per coffee column and find the values where coffee is 10, 20, or 30. And note, I have this @ sign there, and this is how we're able to use this list to generate the values. Run this, and you see we're getting these 3 rows here, and this is again, a very convenient way to dynamically modify your query statement by calling in variables using the @ sign that are generated outside of that statement. We can also use or and pass in strings. So of course, earlier I demonstrated an example using and. We're just going to use the or. As well as if we want to pass in a string, you just use the opposite sign you use for your query statement. Since I use a single quote for my query, I need to use a double quote for any internal strings there. If I don't, then we will have a syntax error and you will get the improper results. So to read this, I want where the amount coffee equals 2 tablespoons and 1 teaspoon, or the amount coffee equals 2 tablespoons, 2 teaspoons. When we run this, you see that we get these 2 rows here that meet the condition set by this query statement there. And lastly, we can compare multiple columns. So I don't use this particular approach too much, but it's definitely worth recognizing that this is a possibility too, where in this query statement, I want to filter the columns where the volume of coffee in teaspoons is greater than the volume of corn. So essentially, I'm going to compare the values in these 2 columns to each other and produce a data frame where those values are true. When we run this, you see that these are the 4 rows where these values are true. And I want to note that we are not modifying our data frame. If I run this here, we're not modifying it. All we're doing is creating a new view of the data frame produced by this statement there. If we want to modify it or create a new data frame, I recommend just creating a new variable. In this case, I'm going to call it df1. That will actually be this data frame here. There's also the ability to use the in-place argument and set that equal to true. And that will overwrite the data frame with the subset data frame by this query statement. I usually don't recommend this because you don't want to overwrite this original table unless you have a larger workflow and this is a process that you're trying to save on your memory. Notably, by default, in place is set to false, and this will produce those same results. Next, let's talk more about summary statistics about our data frame. I mentioned earlier that we can use the describe method, and there's lots of approaches we can use for describe. In this case, I want the 10th percentile, 20th percentile, and 80th percentile. And because I'm passing a percentile, it's going to subset just the numerical data types. That includes floats and integers. If I use the include, this will just find the integer values. As you see here, we're getting essentially the same data frame, but with the default being 25%, 50th percent, and 75th percentile. If we use the exclude integer, so we're actually telling it to remove those integer values from our describe, that just leaves the object data type, and we're going to get these attributes here, the count, the number of unique values, the top value, and the highest frequency for each column. Next, we're going to talk about how to generate new columns. And with Pandas, there are lots of data frame and series methods for this, and it really depends on what else you're doing in the work process. So it's really important to understand all these different techniques. So there's a couple things we can do. In this case, I'm using the index-based subsetting where I'm selecting the 0, the first, and the last column. This -1 means the last column. And I'm just going to create a copy of it and store that as new column df.head. And this will allow us to see all those you can add new columns. So we can assign a new key. In this case, I'm going to use this method where we're going to set is adulterated Boolean. And by doing that, we're going to find the values for the is adulterated column that equal true. So we're going to look at this is adulterated here. And instead of having yes, no, we're going to establish it as a Boolean true, false column. And it's running. And you can see that now we have a new column called is adulterated bool or Boolean. And we're just looking for where this column here was set to yes. If it was yes, it returns as a true. If it was no, it now returns as a false value. And if we look at the D types, you can see that now our new column is a Boolean data type. And this is great for some of your machine learning models. In many cases, storing a Boolean value costs less memory than storing an object data type. So this is a good way to convert to a data frame that requires less of your compute memory. We can also use the insert method. And here it works by you selecting the position you want to insert the new column. You use the new column name, and then whatever array, list, or series you want to pass in. In this case, I'm going to pass in the percent coffee divided by 100. So let me show you what that looks like before we insert that column. Let's look at frac underscore coffee or fraction of coffee. And you can see that we're just taking our percent coffee and divided by 100. So we have the fractional values. I then want to pass this array into this new column data frame in the 0th position. So let me uncomment that, remove this so we can see the update. And then let's look at our new column. When we run the cell, we now have a new column called frac_coffee with that value, essentially this percent coffee divided by 100. Notably, if I were to rerun this, I will get a value error because this column already exists in this position. So be aware that if you run this multiple times within the same cell and you're not regenerating the original data frame, you will get an error. But the column is still there. You just have to comment that out or make the proper adjustments. And this is a good case where you might try except, where you first look for that column in that location. If it's not there, then execute this cell there, and that will avoid this error. Error management is really important when you're performing some of these computations. Let's also talk about the assign method. The assign method's really nice. So let's regenerate our new column there. And by doing this, you can see we have our original subsets. We have our SID, our percent column, and our is adulterated. Assign allows you to create multiple columns at once. And so let's say I wanted to have a column called is high coffee. So we're going to look for the fraction of coffee that's greater than 80. And when I run this, I will get a new column where is high coffee equals true for these 3 rows and is false for the others. But additionally, we can start to add multiple columns at the same time, including those generated from Lambda functions. And so you can see the assign has the benefit of allowing us to generate all these columns with a single method. And when we do this, we're actually passing in functions, we're using clip methods, and we have a Boolean. And really quickly, we've generated a new data frame with a single assign method. This is one of my favorite ways to generate multiple columns because in many cases, I am performing multiple calculations on that data. Again, this is a view. So we actually haven't modified new call df. And what I highly recommend is just creating a new data frame and performing those calculations. And then now you can see the new data frame has those new columns, but you haven't modified new call df. This is just a good way, a good practice to understand when you're creating a new view versus when you're actually modifying the source data frame. And in general, I would recommend creating new data frames versus overriding unless you're ready to productionize and you don't need that traceability. So lastly, let's talk about sorting data, and let's do this together. So I'm going to take my data frame and I'm going to shuffle it by just sampling all of the data. So I'm going to select all the data, sample it, and set replace equals true, and also use a random state of 3 so that this always gives me the same output. And let's look at shuffled df. And you can see here that we are not sorted at all as our SID and per coffee are randomized. So to sort the data, let's just call shuffled df and let's sort the index. So if we just pass sort index, now we're use replace. So we do have duplicates based on how I generated this, but you can still see that the overall data frame is sorted. But we can also sort by different values columns. And so we can actually select sort values and we can use the by argument and let's set by per coffee or percent coffee. And we have the option of setting ascending to true or false. When we do this, we'll get the same sort because our index values and our percent coffee are identical or correlated. So let's set ascending equal to true so you can see the change. And now we have a view of our sorted data. Notably with this particular method, we are still talking about a view of the data. So our data frame is still unsorted until we actually create a new variable. So in this video, we covered a lot of techniques that you can use for your Pandas data frames. And these are all the things that will help your data processing workflow go much smoother and help you plug these data into other techniques like those for data viz or machine learning, or produce new Excel files that have all been pre-processed using a Python-based workflow. If there's other methods you want me to talk about, let me know in the comments below, and I'll see you in the next video. Peace.